Hey guys, I wanted to start out by sharing a little bit about how this course is going to work. So the expectation is that every week in the module of that week, you guys will have the lecture slides, and you can download those into whatever is your preferred device, your iPad, your computer, your iPhone, and you follow along on those slides as we explore that material in this format, this cool online format called a learning glass. Cool, huh? So, this course is called Physics for Life Scientists, and it's a way of showing all the connections that exist between the physical world and the biological world and life in general. And for years, students of biology and pre-meds and biological research needed to take this course and weren't quite sure why, you know? And so the goal here is to really make those connections clear between physics and medicine and biology and marine biology and zoology and animal life, because the truth of the matter is physics is the foundation of all biological, processes. Stuff works, my heart works, my blood is pumped through my veins because of physics. And physics is the language that describes that. This week, we are exploring units and measurement, which kind of lays the mathematical foundations for the course. A lot of this should be review. Hopefully it is. But if it's not, then you get to learn something. Okay? There's another kind of fun, maybe silly component of the course. So if you'll advance to the quote of the week, I always like to put just one quote at the beginning of every week, because I think it's an important reminder that as we become very good scientists, we should also become very good people, because with learning science, there's a ton of power in that. In a world where we have incredible power in terms of genetic engineering, with these CRISPR technologies, atomic power, it's more important than ever to be strong people as much as we are strong minds. So this week, I have a quote by one of my favorite thinkers. His name is Eckhart Tolle, and it says, "You are not your mind." What does this mean to me? This means, well, I think we have this absolutely beautiful tool that's evolved, and that's the human mind, and it allows us to solve all these problems and be incredibly clever. But it's also just a thought-generating machine, right? It generates all these thoughts, and not all of them are true, right? My first thought this morning might have been, is the moon really made of cheese, right? Silly, stupid thoughts that a lot of them will realize how silly they are, but, our mind also makes a lot of thoughts that are, like, are you sure you're really capable of being a doctor? Is this really something that you deserve or you're capable of? Or anything about who we think we are. And the truth of the matter is, we don't always have to listen to it. So the stuff that our mind tells us isn't necessarily who we are. And I think we should always challenge that, especially when those things are limiting beliefs that keep us away from achieving our goals and our dreams. So with that said, I will always start each week with the question, why do we care for that week? Okay. And the why do we care is, what is some obvious connection to the physical world or to the biological world that I can make right away? And so if you'll advance to the why do we care slide, one interesting question is the age of the Galapagos turtle. So we're studying units right now. That's part of the mathematical foundation of physics. And so here's an interesting question. Many of you probably know that the Galapagos turtle can live wildly long. It has a very abnormal lifespan compared to other creatures in the animal world. So a Galapagos turtle can live beyond 200 years of age. Currently, there are Galapagos turtles alive who were born the same year as Abraham Lincoln. That's 1809. You could just think of the wild amounts of history that turtle has lived through and experienced. Everything from the Civil War, obviously, to the World Wars, to not even having a telephone, to now having crazy internet abilities. I just want to sit down and have tea with that turtle. So let's ask the question, how many hours has that turtle lived? okay? Doing conversions like this, unit conversions, quick and easy, is something you will be able to do by the end of this chapter. Okay, moving on to the unit slide. So whenever we're measuring something, we need to know what size chunk we're measuring it in. This is a very, very important question, right? So let's just take something like time alone. For time, you can measure time in seconds, you can measure it in minutes, you can measure it in hours, you can measure it in days, years, centuries, millennia, right? What is the appropriate unit to measure something in? And a lot of that depends on the context or whatever, what kind of experiment you're actually performing. So as an example, I use Usain Bolt, who is currently the fastest human alive. When we measure the time for one of his races, do we want to measure it in seconds, hours, or days, right? Go ahead, take a guess. Well, probably we want to measure it in seconds, possibly minutes, right? If he's doing a 100-meter dash, it wouldn't make sense to measure it in, 0.08 hours, right? So we want to pick units that are appropriate to the specific measurement. So if you'll advance to the next slide, we also have to ask this question: when we're talking about a whole subject like physics or biology or just science in general, right? What are the units that we all agree that we're all going to use all the time, okay? For example, there is this crazy situation where America is still using these outdated British colonial units of pounds and feet. And we have not adopted the more European metric system, even though it's much easier to work with. This is a historical relic that has a lot to do with, I think Americans' pride in their independence. And so one interesting consequence of this was the Hubble Telescope, which was the most deeply viewing telescope in the universe as far as we knew at that moment. And we could take pictures of other galaxies, not other stars, other galaxies, and get these really cool pictures. And the whole astronomical community was super, super excited about it. But we put it up in the air, in the atmosphere, or in space, in orbit around the Earth. And we noticed that the pictures were all blurry, right? So it turns out that a couple of engineers did not convert their units properly. That shows you how important this chapter is, right? This resulted in billions of dollars of several more missions. I think it was 5 missions to actually fix the mirrors because the units weren't correctly transformed in order to get proper measurements. One interesting thing did come out of this, though. A lot of times, great scientific innovations come out of either big mistakes or big tragedies. In this case, a bunch of Silicon Valley computer engineers were like, hey, I bet I can clean up these images, right? So they developed this powerful software to take a look at these pictures they were getting from Hubble that were super blurry, and they used some computer algorithms to make them much sharper. And so while we were fixing Hubble, we could still get some decent pictures, okay? Well, a doctor, that's many of you guys, saw this at some conference at some point. He's like, whoa, this would also be incredibly valuable for mammogram imaging, right? So they applied that same technology to reading mammograms, and early detection of breast cancer has increased tremendously because of this one technology, and perhaps hundreds of thousands of women's lives have been saved simply because one egghead forgot to convert his units. So that's not an excuse. In any case, there is one international system of units. It's called the SI unit, System International. And for force, it's newtons. For energy, it's joules. For mass, it's kilograms. For time, it's seconds. And for pressure, it's Pascal. As far as this unit, this semester as a whole, those are the only ones you really care about. But just know there are an international system of units, and if you start a problem and it's not in SI units, convert it there as quickly as possible, right? So if you have a problem where the mass is given in pounds, convert it into kilograms. If you have a problem where the speed is given in miles per hour, converted to meters per second. Okay? Hope that makes sense. So as far as this video goes, the last thing I want to share is that there are these prefixes that tell you how big your unit is, right? Many of these we know very well. Kilo, like a kilogram, right? Mega, like a megabyte. Or centi, like a centimeter or a millimeter, right? These extend, all the way up to like peta and exa, which we're starting to kind of see in computers a little bit, right? That's after the terabyte. We're starting to look at sizes in the range of petabytes, and just be familiar with that tera means 10 to the 12, and that pico, for example, means 10 to the minus 12, and that nano, which many of us know, is 10 to the minus 9. Get familiar with those prefixes because I will very often use them as if we know, okay? So next, we're going to actually talk about how we know how big a unit actually is, and how we set a standard for measuring that every time, because it needs to be consistent. I will see you in the next video to discuss that.